Okay, today we're in lesson 8.2. Lesson 8.2, solve systems by substitution. Solve systems by substitution.
So if you want to solve a linear system, one way is to draw a graph of both of the lines involved and seeing if you can see the point of intersection exactly and check your answer. Another method, which is a little bit more systematic and a little bit more rigorous, is actually the method of substitution. Let's take a look at an example where you can see the substitution happening in action and see what exactly is being substituted for what. Let's find the solution to this linear system of two equations, y equals 3x and y equals x plus 4. Well, I want to find the value for x and the value for y, which make both of these hold. In particular, this value for y is going to equal that value for y. These y's are going to be equal. Well, that means that if I want, I could substitute in place of this y, its twin, which is this. This equals y, and since this equals y, therefore I can substitute and say this must equal this. So the substitution is really to notice that since the y's are equal, these guys must be equal as well. And so by substitution, I can say that the 3x must be equal to x plus 4. Let me just say that one more time. I'm going to substitute the values for the y. Since y equals y, then this must equal that. So this must equal that. Well, now the y's are gone. So I can easily solve this for x. I'll bring the x's together. I'll subtract x from both sides. And so here I see 2x equals 4. If I divide both sides by 2, I see that x equals 2. So there's the solution, x equals 2. Am I done? Am I done? And no, I'm not. That's just the x value. I still have to find the y value that goes along with the x. Now there's two ways of doing that. Either one of these equations should lead me to the right y value. I can take the 2 and plug it into the first equation for x to get y, or I can plug it into the second. It shouldn't make a difference. Let's plug it into the first. If I plug into the first, I'd see that y equals 3 times 2, and that yields 6. I should get the same answer if I plug into the second. Let's just do that for fun. Plug 2 in here. 2 plus 4, that equals 6. So my answer is x equals 2, y equals 6. Or if you want to write as an ordered pair, 2, 6. And you can check your answer by taking these values and plugging it into each of them and realize that both are satisfied. If I put a 2 in here, 3 times 2 is 6, that checks. If I put a 2 in here, 2 plus 4 is 6, that checks. So it checks. So substitution is to actually take two of the unknowns and set them equal to each other. And when you set them equal to each other, we have this. Let's try another example together, just to sort of get into the groove, get into the rhythm, sort of feeling it, getting that mojo, getting that math joe working. All right, so here I've got a system, x minus y equals 4, and x plus 2y equals 4. And I want to actually now solve the system. And so what should I do? Well, the first thing I'm going to do is actually, I'll take this one. Now, let me just say one thing. There are a lot of ways of looking at this, and there are a lot of ways of solving it. Probably one way of solving for every person out there. So you've got to find your own way. I'm going to show you how I look at it, but it's not the only way. And you can think about other ways that are still correct, but different, and get the same answer. What I'm noticing is, you know what? I'm going to solve this for x. If I solve the very top equation for x, that means I'd have to add y to both sides. And what I see is x equals y plus 4. Now, if that's what x equals from the first equation, then what I could do is I could substitute that same x in for the second equation. So instead of writing x, I'm now going to write y plus 4. And then I'd see y plus 4 plus 2y equals 4. Let's just check it out and see. That's just the second equation. Imagine that being an x. That's actually x. X plus 2y equals 4. X plus 2y equals 4. But I'm substituting in place of x. I'm putting in that stuff. The beauty is that now there's no more x's. I got rid of x. Look, Ma, no x. All I've got now are y's. And so I can now solve this for y. I've got 1 y and I'm adding 2 more y's, so that's 3 y's. And I've got 3y plus 4 equals 4. If I subtract 4 from both sides, then I see 3y equals 0, and so y equals 0. So the answer is y equals 0. Am I done? No, I've got to find out the x value. How do I do that? Well, I can replace the y for 0 in either of these and solve. If I put y equals 0 here for the first one, I see x equals 0. I'm sorry, x minus 0 equals 4. So I see x equals 4. Similarly, if I would put the 0 in for the y in the second one, I'd see x plus 0 equals 4. So either way, I'd see 4. So the answer is x equals 4, y equals 0. Or you could write it as 4 comma 0. And again, you can check your answer by letting x be 4 and y be 0 in each of these and seeing that these are both true statements. 4 minus 0 is 4, and 4 plus 2 times 0 is 4. It checks. So a great way to solve a linear system is to actually substitute. Solve for one of the unknowns, and then take that value and insert it for the unknown in the second equation. In this case, solve for x, and then replace the second x by what you found, and then you're home free.
All right, now for those of us who may be a little bit confused, notice what they did. They got two equations. They took the first equation and they solved for x. And they could have solved for y, but it was easier to solve for x because it's positive. The y is negative, which would mean an additional step. So they solved for x. So they wrote the equation down, x minus y is equal to 4. To solve for x, you must get rid of that negative y. To get rid of the negative y, you got to say a positive y on both sides. A negative y, when combined with a positive y, is going to cancel out. You bring your x down. You got 4 plus y. You can't combine those because those terms are not alike. So all you can do is represent them. The y is positive and the 4 is positive. So they write it as y plus 4. So x is equal to y plus 4. Now we take the x is equal to y plus 4 and we're going to substitute this right there. So in place of x, we're going to put down y plus 4. Why? Because x is equal to y plus 4. All right, and then after doing so, we'll end up with y plus 4. That's what the x, y plus 4, plus 2y, and that's equal to 4. Now notice what you have. Now all your variables are the same, y and y. That's why we call it substitution, because in this case, we substituted the x and use y instead. So once again, we got y plus 4 is equal to 2y. Excuse me, y plus 4 plus 2y is equal to 4. Okay, after doing that, now all we're going to do is solve for y. So we're going to combine all terms that are alike on the left-hand side first. So here we have a y and a 2y. Y plus 2y is 3y. And we bring that 4 down since it's nothing to combine it with. On this side, we got a 4, so we just bring that down. It's sitting by itself. So now we got 3y plus 4 is equal to 4. All right, so this is the two-step equation, multiplication and addition. So we're going to do the addition first. So what's the opposite of addition? Subtraction. So minus 4 minus 4. So that's gone. Positive 4 when combined with a negative 4, that's gone. So we're left with 3y is equal to 4 minus 4, which is 0. You're trying to solve for y, so you end up dividing both sides by 3 because it says 3 times y. So divide by 3, divide by 3. And you end up with y is equal to 0. All right, now since we know that y is equal to 0 then, to find the x value is simple. Look at either one of the equations, the top one or the bottom one. You normally pick the one that's easiest to work with, and the top one is easier to work with. All right, so the top equation says x minus y is equal to 0. What was y equal to? 0. So in place of y, we put 0. So we end up with x minus 0. X minus 0 is just x. Bring the 4 down, and we find out that x is equal to 4. So step 5, our answer is going to be x is 4, y is 0. All right, next we're going to use a graph to estimate the solution of a system. Use a graph to estimate the solution of a system based on example 2.